Hello, gentlemen.
Well, I'm going to be coming back from.
Hello, Nora. Hello.
I'm good. Break your back. So what I assume.
So we lost 0-9. Yeah.
I could never.
I'm gonna guess that Western the only person that isn't honest.
Say that again?
I've been in circles.
Just don't lose. Just don't lose.
I didn't lose.
Don't lose.
I'm losing.
Just don't lose.
I'm not losing. I lost. I lost. Freaking hard. I'm blaming you. Apparently, more than half of it. What is that?
I don't even know.
I think I'm pretty good. That's it.
Yes.
There's a stain on my desk. And it's not good. Oh, it's sticky. It's really sticky. The new desk. Oh. It's right there. He's gonna make me stand back because he said another one. Yeah, I did.
You're still angry.
Wait, only kind of. It's okay. It'll just.
I know.
Thank you. Could have done that more politely.
I did not do it. I didn't do it.
The entire class.
Like I like the first part. Thank you so
What?
much.
It's like
like
lot.
7 times.
Dude.
It is supposed to be more. So like opening statement and then.
I forgot that it was Thursday.
Once you get going, it's not gonna hurt you.
Okay.
Because you're basically just
Set up
explaining.
listening to.
Yeah, but like the Craigslist thing.
Megan?
4 days.
Listen to Joy and
And the buses have like they.
Okay.
So then we can also do that.
Which turns out that was.
Good afternoon, ladies and gentlemen. Grab some scratch paper. We got some practice problems for you. Take out your periodic table. You're going to need that as well. If you want scratch paper, it's up here at the front desk. We're going to put a few more notes on our periodic table. So if you want a marker or a colored pencil or something like that, please feel free to come up and grab them. Oh, lefty.
Stop getting mad.
Hang on.
It's not.
How much is, put this on?
And like, I cleaned
I don't have, I don't have any.
I needed to take the test.
Cause he needs.
All right, on your paper, ladies and gentlemen, I want you to name the 3 compounds that are on the left-hand side of the screen, and I want you to write 3 formulas for the 3 names that are on the right-hand side of the screen. These should look like those when you're done. Those should look like these when you're done. You've got 5 minutes, ladies and gentlemen. Go.
That's what it looks like.
No,
Maybe
it's
I'm
doing
dyslexic.
exactly what we did yesterday. Are we ready, ladies and gentlemen, or do you need another couple minutes? I'm sorry, do I know that? Anyone? We're good? All right. Well, then let's get going here, ladies and gentlemen. Awesome. So our first compound, Mg3P2. Now again, the reason it is Mg3 and P2 is because the total charge on any ionic compound always has to be what? 0. And when we have 3 magnesiums combining with 2 phosphoruses, we get a total charge of 0. That was the crisscross method. That's what we showed you. That's what we will get back into when we take these and write formulas for them. When you look at a formula, though, first of all, you look at it. How do we know this is binary? Okay, well, it's one compound. How do we know it's 2 elements?
So there's 2 capital letters.
Thank you. Capital letters will tell you how many elements are in your compound. Every time you hit a new capital letter, ladies and gentlemen, that's going to be a new element. There are 2 elements in this compound. Now, what is the other thing that is important for a ionic compound? The first element needs to be a what?
Metal.
First element needs to be a metal. Now, you will eventually get to learn where these are, and maybe some of you have a pretty good idea of where these are on your periodic table. But when you look at a compound and you're looking for a metal, start over on the left-hand side. Metals are on the left-hand side. Start looking that way. If you're looking for a non-metal, you have to look at the far right-hand side above that bold zigzag line. Okay? So, with this compound, ladies and gentlemen, name it. Ethan, name it for me.
Magnesium phosphide.
All right. This compound is magnesium phosphide. That is what you should have had, ladies and gentlemen. Now, a couple of things. Some people asked me this the other day. Is this 2 separate words, or do they kind of run together into one? They should be 2 separate words, but if you were to write them as one, I'm not going to mark it wrong. Number 2, minor spelling errors I will accept. You forget the I in magnesium. You put phosphoride, OR, back in here. I will accept that. Hopefully, eventually, you will get to learn where to end the names to put that IDE ending on. Now, what I will not accept is if you leave this phosphorus or if you do something like phosphorine, because it should not end in IDE. These should all end in IDE as a compound. Questions? So what we've done here is we've named the metal magnesium, we've named the non-metal phosphorus, and we've changed the ending to IDE. That is exactly what we do when we name these. K4Cl. K4Cl. Safira, what would the name of that compound be? K4Cl. Potassium carbide. Perfect. What?
There's no L on this one. It's just C.
There's no L on this.
K4Cl.
Wait, what?
You said K4Cl.
I'm sorry. Okay, sorry. My bad. Then I said it wrong. Should have been K4C. Sorry. My bad. But what you named is correct. K is potassium. Now, please. This morning, Chemistry B students, second half of the trimester, I gave them a compound with potassium in it, and they start writing their formulas with the capital letter P. That is not potassium. That is phosphorus. Okay? If you're not sure of the symbol, please don't guess on them. Again, a lot of times the first letter of the name is the symbol, but it is not always the case. So if you were to write a formula with P at the start and you're talking about potassium, that's not going to be right. So potassium, C is carbon, carbon becomes carbide. Any questions? All right. Then the last one. What would be the name of the last one, Stephanie? I'm sorry, one more time. Zinc fluoride. Wow. Sorry about that. That's a terrible spelling of fluoride. Zinc fluoride. That doesn't look much better, but it is. Okay, there we go. Zinc fluoride. Zn zinc, F fluorine, zinc fluoride. Again, we do not know yet, we will after today, how to write compounds with groups 3 through 12 in there. Unless I give you the compound, okay? So by me giving you zinc fluoride, zinc only has one charge, ladies and gentlemen, okay? So I've given that to you. It is on your periodic table. I can give you compounds with zinc because you should know how to write them. I can give you compounds with silver because you should know how to write them, and we will take care of the rest of those today. Questions? Okay, so now what we're going to do is now we're going to take a name and we are going to write a formula. All right, Jade. So germanium sulfide, Jade. What would you get for a formula for that one? What is it? So just read me like your letters and numbers and things like that. All right. Ge2S. Now I'm going to go back here a second. Didn't do anything wrong. I'm just going to go back. When you're given a name like this, the first thing you need to do is write the symbol and the charge for both your metal and your non-metal. So germanium is a +4, sulfur is a -2. Now we are going to do what we call a crisscross method. I am going to take just the number 2 here and put it down by the GE, and I'm going to take just the number 4 here and put it down by the S. And I get Ge2 S4. Nope. Sorry, Jade, you had it wrong. Okay, what do we want to change here, Jade? Yeah. So let's make it GeS2. Thank you. Okay. So, well, how did we get from here to here? What did we have to do? Someone, tell me. We had to reduce it. The only place the crisscross method fails you, it never fails to get you a total charge of 0. The only place it does fail you is it doesn't reduce your formula into lowest terms. We only want one way of writing an ionic formula. Writing it this way, the total charge would be 0. Absolutely nothing wrong with that. The problem is we can reduce it, so what if one person writes it this way and another person writes it this way? We said we can't have multiple ways of writing the same formula. So with an ionic compound, we always reduce them into lowest terms. And what I mean by that is we're going to divide this 2 by 2 and this 4 by 2. That gives me a 1 and a 2, and since I never write ones, Jade is absolutely correct here with this answer. Questions? All right, Lily, gallium nitride. What would be your formula for gallium nitride?
Ga3 and then +3 and then N -3.
Like that?
Well, they're at the top and then.
Okay, sorry. Okay. So we want this up here. We want this up here. Okay, what do you ultimately get, Lily? What is your final answer if this were a test and you had to write it down?
GAN.
That is absolutely correct. GAN. Now, the +3 and the -3, I wasn't expecting you to do that with me right away. You were doing that, and that was fine. All I wanted was that, so you're good. This -3 comes down here. This +3 comes down here. But a 3 and a 3 can be reduced. So when we reduce them, they reduce out to GAN. Questions? Okay. Aluminum phosphide. Aluminum phosphide. All right. Linda, what do you got for me? Just like that? Good. Okay. Aluminum +3. Phosphide -3. Again, we crisscross them. Al3P3. We can reduce both of these by 3, giving us exactly what Linda said. Questions, ladies and gentlemen? Yes, no, maybe so. All right. All right. Then here's the next one that I want you to write a formula for me. Write me a formula for chromium oxide. Well, what problem are you having right now, ladies and gentlemen? Chromium is an element that is in that area where I said we cannot tell the charge, right? Okay? What's V? What? But what is it? Why is there a V in the middle of that name? We haven't done that with any others. No, it's not. Good guess. What state would that be, by the way? I mean, you're right. There will be a time where we will put the state in there like solid liquid gas, SL and G. That is a good guess. I just don't know what you were thinking V would be. You were more right the first time you were talking. What is that V, Jay? In what? How is V 5? Roman numerals. Roman numerals. Now I'm going to give you I used to walk uphill to school both ways 5 miles on a snowy day story right now, ladies and gentlemen. In about the late 80s, maybe even a little bit before that, they changed the way they name compounds just a little bit. There are elements like iron, like chromium, like cobalt, like nickel, like copper, that have more than one charge to them. And it's not that we wanted this to happen, but what we noticed is that in a certain compound, copper acted like a +2. In another compound, it acted like a +1. So we eventually scientists realized, okay, it can have more than one charge or more than one oxidation state. Okay? So that created a problem for them because we had to be able to have a naming system where we could account for multiple charges. Well, what they used to do is they used to go back to the old names of things. So iron, its symbol is Fe. And its symbol is Fe because it came from the term ferrous. Okay? That is where the Fe in iron symbol comes from. It used to be called ferrous. And ferrous oxide was a compound between iron and oxygen. And then there was also another compound called ferric oxide. Ferric and ferrous oxide, the difference between them was one used the larger charge, +3, one used the smaller charge, +2. So years ago, you had to know what charge a metal would have because the name didn't tell you. Well, they decided this is dumb. It is just, people don't memorize every charge of every metal on there. So in the 80s, they changed the naming system a little bit, and they now use Roman numerals in it. Now that Roman numeral, Jade is absolutely correct. The Roman numeral V represents the number 5. But what it actually tells us is the positive charge on chromium. So now, I'm going to tell you right now, in this compound, chromium is a +5. So please, now that you know what the charge is, now please write me a compound for chromium 5 oxide. All right, anybody got it for me?
CR2O5.
Okay, let's see if he's right. Chromium symbol is Cr. Given the V, its charge would be a +5. Oxygen symbol is O. Its charge is a -2. We take the 2 down, put it by the Cr. We take the 5 down, put it by the O. We get Cr2O5. Can the 2 and the 5 be reduced into smaller numbers? No. Boom, you're done. You are done. That's it. Okay? That is it. Now, that means, ladies and gentlemen, that if I give you a name of something in this area, groups 3 through 12, in the name, I will have to tell you the charge on the metal, except for 2 metals. Which 2 metals do I not need to tell you the charge of? Zinc and silver, because I've already given those to you and they're already on your periodic table. So what that means, ladies and gentlemen, is that if I give you anything else in there, if I give you the name, you should be able to write a formula for me, because in the name I will have to give you the charge. So, for example, I want you to write these 2 compounds, the formulas. Copper 1 chloride and copper 2 chloride. Please write formulas for both real quick. All right, who can give me either one? Divine? Which one are you doing first? Copper 1 or copper 2 chloride? Okay, what do you got? CuCl2. Perfect. Copper 1 chloride? CuCl. Oops. Don't know exactly what that was. CuCl. The only difference between these 2 compounds is what the charge on the copper is in there. Here it's a +1 with chlorine, which is a -1. That's why it's just CuCl. Here copper is a +2, chlorine is still a -1. Here you get CuCl2. Questions? Now, one thing I will tell you, the Roman numerals only ever go with metals. Non-metals don't ever change their charges. Non-metals are rock solid. Chlorine is always a -1. Oxygen's always a -2. The only ones that we ever have some trouble with are those transition metals in the middle part of the periodic table. Now we should do something that makes your life easier for you. What is that? Answer the phone, apparently. Mr. Brandon? I do not know. I don't think he's subbing for anybody, but I don't really know where he goes when he's not supposed to. Sorry. You're welcome. Bye. Okay. Sorry. What was I? Oh, what should we do now? What should we give you now? You just did. Let's take out our periodic tables and let's write down what these Roman numerals mean in case you're not familiar with them. Okay? So take out your periodic table, ladies and gentlemen, and we're going to go through the first 10 Roman numerals for you. Also, we are going to do something else. We are going to tell you Roman numerals and we are going to tell you prefixes because we are going to need those in a matter of a few days or so, ladies and gentlemen. So I am going to, at the bottom of my periodic table down here, ladies and gentlemen, I'm going to find a good pen color I like, and I am going to take and I am going to add some information down here for me. Okay? So I'm doing this at the bottom of the periodic table because I have a nice wide open space here. Okay? The number 1, ladies and gentlemen, in Roman numerals is represented by I. Now, you may or may not see that I with the lines above and below, okay? But the number 1 is I. This is also mono. Mono means 1. And we are going to get in a naming system in a few days or possibly a week or so that uses prefixes to represent numbers. You've all heard of carbon monoxide and carbon dioxide. Well, those are a different kind of compound that we name and we do use prefixes. So, the number, the Roman numeral, the prefix. Fair enough? Okay. So then for 2, that is I. And the prefix is di. Di. Okay. The number 3 is represented by I. And that is tri in a prefix. Okay? Questions? Anyone know what the Roman numeral for 4 is? IV. And again, you may see the lines written on top. You may not. It depends on the type of typeset they use. Anybody know what the prefix for 4 is? Tetra. So we'll keep going. 5. Jade said was V. He was correct. Prefix. Funny looking building in Washington. Extra side on it. Penta. 6. Roman numeral. VI. V and then the I. V means 5. The Roman numeral with a 1 in front means 1 less than 5. The one after it means 1 more than 5, 6. Okay? What's the prefix for 6? Disappointed. Hexa. 7. VII. Prefix. Hepta. 8. VIII. Prefix. Octa. 9. IX. X is 10. I in front means 9. Prefix nona. Nona. And finally 10. X. And the prefix is deca. Okay? So our number, Roman numeral, prefix. Okay? That's going to take care of you for a lot of what we're going to be doing in this next unit as well. Okay? Questions? All right, so here's what you've got, ladies and gentlemen. You have got 20 minutes to take out this worksheet and do as many of these as you can get done. Now, the only section on here that you might still struggle with is this part right here where you have a formula and it involves using these in groups 3 through 12. So skip that, and in 20 minutes I will come back to it and I will show you how to do a name that has to have one of these prefix or one of these Roman numerals in it. Don't do it now. Okay? I will show you how to do that. Now, I want to point out one last thing. Monday, you got a quiz, and it's going to cover all of this. All of this binary ionic compounds naming and things. So if you can do this worksheet right now, ladies and gentlemen, minus these that we haven't given you, you will be doing just fine. If you want to go back and work at a lab station with a group, you are welcome to. If you want to work on this at your desk, you are welcome to. If you want to get together in a group of 7 and go back there and work on it, I don't care. Okay? But let's get some work done, ladies and gentlemen. So I got 20 minutes on the clock for you. Then I get you back for a few minutes. If you have questions, if you need something explained better, now would be a great time to call me over and ask me. You bet. You should have one though, Crystal, because I gave it out the day after the test was handed back. But here you go. Here's an extra one just in case. Okay? Leave me your phone, sign out, and you can go. Up until you get to ternary ionic compounds. So it's like page 4. Yeah, actually you can leave your phone and you can go now. I can let 2 people go at the same time, not a problem. You gotta wait. Katie's gotta go, and then when either she or Leah gets back, you can go. Okay. Larry, what can I do for you? You need to be as ready for it as you can be. Now, what I would like you to do is come see your home base one day and go over your test. Hopefully, get some corrections to it.
I haven't, but I wanted to, but I haven't.
You don't have to come see me, but before we do it, here's the thing. People get in a pinch, I let them take it, but they don't do well. I'd like you to come see me, I can do some corrections. If there's things you're still not sure, we'll go over them, and then you can take the test as soon as you want after that.
And then for the retake, can I still use my like retake?
Yes, you may.
Oh.
Yep.
Yep. You can use your periodic table. You can use your proof.
Yeah.
Just like on the test. No. Sorry. No, I do that all the time. I'm a big fan of cutting and pasting. Sometimes I that makes sense. I do that all the time. There's stuff like that on there, but I haven't like it's up. I'm not going to. Say that so that it's spell it correctly.
Come in, Valeria.
Okay.
get all of them. Yes. They're actually clear. Yes.
I know they talk
I don't know either.
I thought they were talking.
I never talked about it.
Yeah, go ahead.
I was looking for a cat because I'm gonna get one, and I found a cat.
A four-legged furry thing. It's good for hunting. So anyway, I'm sorry. Go ahead.
And do you want to guess what its name is?
Did you name it or? Okay, it came named.
Well, I did.
Annoyance,
No,
pain, independently stuck up.
Burger Wizard the Third.
What?
Burger Wizard the Third.
And you're leaving that name?
I'm still. I'm gonna see it.
Because believe me, the cat will still ignore you if you call it a different name.
No, yeah.
So,
I want to see it, but if I can.
where is he at? Is he at a shelter? Is he at a private person's house? Or? I'm not a big animal person, sorry. In my house, we have a 10-minute rule.
What is that?
That means it needs to stay underwater for 10 minutes before it's welcome. Okay. I'm not fond of them, but we had them when my kids were younger. We had fish, we had hermit crabs, we had all kinds of things that they never wanted to take care of.
What do you mean by you can hold it stuff underwater for 10 minutes?
No, it's just I'm going to put it underwater for 10 minutes, and if it survives, it's welcome in my house. And if it doesn't, well.
So what about your kids?
Luckily, we put the rule in after we had kids. My wife wouldn't let me put it in before we had them.
So are you upset at that or not?
What's it?
Are you upset at that or not?
No, because now my kids are older. I'm through with that stage of my life. Kids are wonderful at times and frustrating at others. So sometimes you have to take the good and the bad together.
Yep.
Any questions? It is. Start over here. Because remember, we're working on here, 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 and here. A couple of them make them money here, but that's, you're right, it is. So like here's the name. And you'll just get used to it after you're looking up a little bit. But you're right. If there's something you absolutely cannot find, please let me know and I will help you. Okay? Just so you know, ladies and gentlemen, we got about 4 minutes left, and then I'm going to show you how to do that last part. So if you have any questions of me, call me over, let me know. I'll give you a hand. Tomorrow, we may introduce turn area on the compound, but those will not be on the 10th. Okay. So what it will probably do is we'll give you a little bit more time to finish up this last part that I'm talking about, where you have to name it with transmission metals. But if we do, we'll just be getting into it. But also we have a short period because of the cutoff. Yeah, that's right. We have a short period, so we're probably, if we get into ternary, we'll just be barely introducing. Yep.
All right, come on back to your seats, please, ladies and gentlemen. I want to show you how to do the last few problems on that sheet. Then we'll give you some more time to finish it. All right. All right. Have you ever heard of reverse engineering something? Correct. Okay. When you engineer things, you put them together to make something bigger out of them. Reverse engineering says you take what's there and you break it back down into the little pieces that make it up. When we are given a name, it is very easy for us to see what the charge of the metal is because it's written there as a Roman numeral. Where we are going to have problems, ladies and gentlemen, is when you have to put a Roman numeral into a name. Because you have to figure out what the charge of that metal was. Now, there is a way I'm going to show you how to do this, and it is not a complicated way, but it does have a few steps. The other thing, ladies and gentlemen, if you are required to put a Roman numeral in a name, I will literally let you know. I will say this compound needs a Roman numeral in it. So you do not have to worry about checking which compounds you should and should not put a Roman numeral in. But on your quiz on Monday, there will be a compound there that I'm asking you to name, and in parentheses it will say this name requires a Roman numeral. Okay? So, we're going to start by giving you a compound. Okay? With a transition metal in it. Transition metals are the ones that are on the periodic table that are in that area. Okay? that are in that area between 3 through 12. Okay. So, we are going to give you the compound manganese, so Mn, and we are going to have Mn3P4. Okay? Now, I've got a lot of boxes here, but here's what's going to happen. We are going to start out with the nonmetal. Why? Because I know two things about this nonmetal. I know what the charge of phosphorus is. What is the charge of phosphorus? -3. I'm going to put that in over here. And I know how many phosphorus are in this compound. How many? 4. So I'm going to take that -3 and that 4 and I'm going to multiply it together. And what does that give me? -3 times 4 gives me -12. Now when I come over to the metal, I know that the total charge on a compound always has to be what? 0. So if the negative part is a -12, what does that mean for the positive part? It has to be a +12. Now I don't know what the charge of the positive ion is, right? But I do know how many there are. How many? 3. So what number times 3 would give me 12? Therefore, you've just figured out what the charge of your metal is. And what I mean by reverse engineering is we take the charges, we crisscross them to get a total of what? 0. Now we're saying, okay, let's work backwards. Okay, what's the negative charge? It's a -12. The positive has to be a +12. So if I'm now naming this, ladies and gentlemen, when I name this, it's going to be manganese. And be careful, this is not magnesium. How do I write 4? Phosphide. Questions? Okay, let's try another one. Can I erase this or do you still need it? Okay, here we go. All right. Now, let's try another one. Let's do SNO. Now, tin is not in that middle section, but what did I tell you about tin yesterday? It can be a +4 or a +2. So we still need to figure out which one it is. We begin with oxygen. How many oxygens are in this compound? 1. What is oxygen's charge always? -2. Which means what has to be the charge, the total charge here? -2. Which means the positive charge must be what? How many of them are in the compound? So what's the charge of the ion? +2. Name it. Good. Please remember, the reason we're going through all of this is to be able to put that in there. That charge. Okay? Now, I don't know if you noticed it on the last one or not, but the formula on the last one was Mn 3P4, correct? And it was manganese 4 phosphide. People ask me, well, Mr. Brand, can't you just undo the crisscross method? Well, manganese ended up being a +4 charge. Here's where the 4 came from, right? What's the charge on phosphorus? So yes, this one we just uncrisscrossed it, correct? And it worked. Gave us the charge. Did we uncrisscross here? Why couldn't we uncrisscross here? And what did we end up doing on this one that we didn't on this one? So that reducing can sometimes mess you up if you try to uncrisscross. If you try to uncrisscross, I don't guarantee you are going to get the correct answer. Because if we uncrisscross this, it would make tin a plus what? +1. But it really isn't. It was a +2. This was a -2. They did end up getting reduced. Okay? So we've got to be careful. It's not just a matter of we can uncrisscross them to get them back because they may have been reduced. Okay? But you can do this every time. And the last thing you solve for, which is the charge here, will be what you put in as your Roman numeral. Okay? And again, just like I did on this sheet, where I said all of these here need a Roman numeral in them, I will do that on a quiz, on a test for you. So in other words, I don't want you searching through 40 problems and going, okay, which ones need a Roman numeral? I will make that very clear for you that this one and this one need a Roman numeral in the name. Now, yes, you got to go through a little bit of work here. But I'm telling you which ones you have to do it to. So it's not a matter of you're looking at every single one. Questions? Okay. Again, if you want to copy something like this down onto either your pink sheet or onto your yellow sheet, it's 100% up to you. More important is, can you do this if you had to on a test? Because right now, you should be able to complete these. And if you do one and you can't, and you're like, I don't remember how to do this, that's when you're going to need to ask me for help. Okay? Now, I was talking it over with Katie a minute ago. She asked if we were going to get into something new tomorrow or not. Tomorrow we have the PEP assembly during 5th period. So that means tomorrow our 4th period and our 5th period classes are going to be shortened from like 71 minutes to like 40 minutes or something like that. So we are going to give you more time to work on this. We're going to give you time to do these. I will give you a few more practice problems at the start. So the question of will we, probably start something new? I hope to get into talking about ternary ionic compounds, but I don't know. We'll have to wait and see how much time we have tomorrow. Okay? Questions? Again, I'm not collecting these. I'm not grading these. But the more you do these, the more you practice, the better you are going to be. And if you are doing this at home, if you are doing this during a study hall, and you're sitting there going, man, I just don't know if I'm doing it right or not, you can always go back into Moodle, or I'm sorry, not Moodle. You can, wrong one. You can always go back, ladies and gentlemen, into Canvas, and the answer keys for this worksheet are in Canvas for you. So there's the class, not the item bank. I'll get to it eventually, ladies and gentlemen. Unit 3 answer keys, ladies and gentlemen. Everything you need is there. Binary ionic compound worksheet key. There are the answers for you, ladies and gentlemen. Everything's written out for you. So don't be in a situation where you're not sure if you're doing it correct. Use the answer keys to check and see if you are doing it correct.